Okay, so in 5.5, we talked about inequalities within a triangle. We said that the smallest side is going to be opposite the smallest angle, largest side opposite largest angle, and then the reciprocal of that, the converse of that, which is that the largest angle is going to be opposite the largest side, that kind of thing, right? So in exercises 1 and 2, it said to list the sides or angles in order from least to greatest. So obviously, if I gave you the angles, I want the sides. If I gave you the sides, I want the angles. So if you look at number 1, it says to least to greatest. What's the smallest side here?
Oh, no, the smallest side is AB.
AB, good. And then what comes next? BC, and then AC, good. In order from least to greatest. So just be really careful because it would stink to get that wrong because you didn't pay attention to like the least to greatest, greatest to least, like if you switch those. Number 2, what would be the least or the smallest angle?
R.
Angle R, then
T.
Angle T, good. Angle S. Super easy, right? Okay, and then we got into the triangle inequality theorem, which said that the sum of any two sides has to be greater than the length of the third side. So this one says, tell whether the side lengths can form a triangle. So if I look at number 3, I would take the two smallest sides, right? 18 and 35, is that going to be bigger than 37? Yes, so this is a yes. And then 4, 3, 3, and 6? No, because 3 plus 3 is 6, not bigger than 6, right? Did you do your experiment yesterday with all your free time? No? All right, number 5 says Jeremy wants to build a triangular toy using sticks. He has one stick that's 12 inches and the other that's 10. What are the possible lengths of the third side of the triangle, Gio?
Greater than 2, but less than 22.
Good. Greater than the difference, which is 2, but less than the sum, which is 22.
On the homework, I just put like 2 examples in between those numbers.
Okay. It's not that specific, so homework is fine. Yeah. Your test will literally like say something like greater than blank, less than blank. So you'd be really specific. Okay, homework. Okay, so 34 said describe the possible values of x. So what we know is that the sum of each of the two sides has to be greater than the length of the third side. So you're actually going to set up multiple inequalities. Each pair of sides. So if I picked 6x minus 11 and 3x minus 1, the sum of those two have to be greater than 2x plus 3. And then if I said 3x minus 1 plus 2x plus 3, those two would have to be greater than 6x minus 11. And then the third pairing would be 6x minus 11 plus 2x plus 3, and that would have to be greater than 3x minus 1. So then I'm going to solve these. I'm going to combine my like terms here. 9x minus 12 is greater than 2x plus 3. 7x would be greater than 15, and x has to be greater than 15 over 7. Then do the next one. Combine like terms here. 5x plus 2 has to be greater than 6x minus 11. And then I'd get x would be actually less than 13, because if you wrote that in the right order, it would be read as x less than 13. And then the last one is 8x minus 8 greater than 3x minus 1. So 5x has to be greater than 7. And x has to be greater than 7/5. So your goal here is really to find the smallest value and the biggest value, right? It's got to be greater than, and you want it to be, like if you set it up as inequalities, you want it to be the most restricted thing. So if I start with this one, this is 2 and 1/7, right? So if I did 0, 1, 2, 3, 2 and 1/7 might be here, right? And it's got to be bigger than it. So it's got to be everything to the right of that. Then the next one said it's got to be less than 13. So if I had extended this line all the way out, at some point I would have hit 13. It's got to be less than 13. So it's got to go that way. And then the last one says it's got to be greater than, this would be 1 2/5. So 1 2/5 would be about here. And it's got to be greater than it. So it can only work for where they all work, which means if I picked a point from this section here, it's too small for the green, right?
So you would go to 15 over 7.
Exactly. Wherever it's restricted and all three lines overlap. So it's got to be bigger than 15 over 7, but less than 13.
Yeah, that makes sense.
It's definitely tricky. You have to like think about it. But yeah, that's how you would do it. You want to go to where it's the most restricted. Okay. And 12 said in triangle RST, which is a possible side length for ST. So I know that the first thing I would do is find that missing angle, 65 plus 56, 121, subtract that from 180, and I get 59. So when I'm looking at ST, 59 is in between these two, which means it has to be bigger than 8. That rules out this one, and this one, and it gives you 9. So you had to first find that missing angle and then realize that that angle is bigger than the angle opposite the 8, which means that the side had to be bigger. Yep.
I just didn't put 9 because like you can't determine that. Like just because it's bigger doesn't mean like it's the next.
Right, that's why it says what's the possible length. It's not saying what is the length, right? If it had said what is the length, you can't figure that one out.
Yeah, that's fine.
Yeah, but it says what's the possible length, so that one can work. All right, so we're going to talk about inequalities in 2 triangles now. This section actually covers indirect proofs. We are not going to, which is one of the reasons why I updated your notes, we are not going to talk about indirect proofs. Okay, I'll tell you what they are, but they're kind of crazy, so we're going to skip it. And it's on your test. This is going to be the end of the material that is on your test, which is Tuesday of next week. So inequalities in 2 triangles, meaning we went from just the inequalities in the one single triangle to now comparing 2 triangles. Okay, good news is they're pretty brief. We're going to cover 2 theorems and then how to use it. The first is called the hinge theorem. Okay, remember that the number's not important. The number just means that it's the 13th theorem that's in chapter 5. What's important is the name or the explanation. So the hinge theorem says if 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is larger than the third side of the second triangle. So the first thing that must happen is that the sides have to be congruent. Like if you look in this first one, AB has to be marked congruent to DE, and then AC has to be marked as congruent to DF. If that's true, and then you look at the angles in between them, they are no longer the same. If the angles were the same, these triangles would be congruent in that side angle side. But we're saying that what happens here is if you could picture a hinge, like the hinge on a door or the hinge on a latch of some sort, right? If you have a hinge, it means that the one part of it is welded together, right? If you swing the doors open, the further open they go, the longer the distance between them would be. Makes sense, right? Common sense says if this is bigger than this, then this side has to be bigger than this side because that's the side that's going to connect those two. Okay? So they call it a hinge theorem. It literally looks like a hinge. The 2 sides have to be congruent, and then the further apart you spread them by that angle, so the bigger the angle, the larger the side. So if this was reversed, if I had said angle D was smaller than angle A, then I could say the side opposite D, which is EF, is smaller. It's bigger, than the side opposite A, which is that BC. Easy stuff, right?
Yeah.
Okay. This is just the reverse, the converse to the hinge theorem, which again, number's not important, especially because that's the wrong number because that says 6, 6, and this isn't the right chapter. This says the converse of the hinge theorem, which is if 2 sides of one triangle are congruent to 2 sides of another triangle. Now we're saying that sides are congruent, and the third side of one is longer than the third side of the second. Then the included angle of the first is larger than the included angle of the second. Oh, and your little picture got overlapped. This is the J. So the same first part of the F is the same, right? The 2 sides have to be marked as congruent. So in the diagram, HJ is marked as congruent to LM and GJ is congruent to KM. If you already established that 2 pairs are congruent, this time the given information is that the side GH is bigger than the side KL. If that's the case, then I can assume the side or the angle opposite the larger side, which is angle J, is bigger than the angle opposite the smaller side, which is angle M. That's it. So hinge theorem is you're given information about the 2 sides and an angle, so you assume the length of the third side comparison. The converse is you're given information about all three sides and you're making an assumption based on the angle. Okay. All right, so this is how it'll get applied. It says example 1 says given D is the midpoint of AC and angle 1 is less than angle 2, what can you deduce or what can you determine based on that information? So these are already marked, right? AD is marked as congruent to DC. What's the other piece of given information that you need in order to get anywhere on these?
The reflection.
Good. This shared side, right, would make them two triangles with two pairs of congruent sides. So then the other piece of information is that angle 1 is smaller than angle 2. What can you figure out from that?
BC is smaller than
BC is smaller or less than AB. So this was smaller, this is larger, side opposite the smaller would be smaller than the side opposite the larger. Easy stuff, right? It's a good way to end a chapter. Example 2 says complete with less than, greater than, or equal to. Those are actual side lengths, not labels. So this is angle 1, right? Here's angle 1, here's angle 2. What information do you know about these diagrams that's part of the if? You've got, these are congruent, right? 4 to 4, and the reflexive side to the reflexive side. So we've got two pairs of congruent angles. Then if I look opposite the angles that I'm trying to figure out, I've got 4 and 3. So, good. Angle 1 is greater than angle 2. Yep.
triangles have to be congruent.
You have to have two, no, they're not congruent.
I mean, there are two sides.
You have to have two pairs of sides. Yeah. If you had all three pairs of sides, then they're congruent, and so it would be equal. So like if this was a 3, now it's side, 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 they'd be equal to each other.
No.
Angle 1 is greater because here's a 4, right? Here's a 3. Opposite the 4 would be bigger than opposite the 3. Example 3 says find the range of values for K. So again, you've got the congruent sides here. You've got the reflexive side. So then I've got this third side, 18 and 19. What's true about the relationships of the ones opposite? Opposite 18 would be what to 38? 5K minus 12 would have what relationship to 38? Less than, right? Opposite 18 would be smaller than opposite 19. You with me so far? And then I just solve it. So 5K, this should be less than, is less than, add the 12, 50, divide by 5. And K has to be less than 10. Sometimes you'll see an inequality with both sides. What's the smallest this angle could be? The 5K minus 12.
9.9.
What's the smallest it could be?
Oh, 1, 0?
It could be like 0.1, right? So that's the other end of your range. 5K minus 12 must also be greater than 0. It can't be 0, okay? So 5K would have to be greater than 12, and K would have to be greater than 12/5. So now we have a range in between 12/5 and 10. Does that make sense? It can't be 0, right? An angle can't be 0, and it can't be negative. So every angle would have to be greater than 0, but less than whatever the other part is.
How come it can't be 0 instead of 12?
Because you can have an angle that's 0, right? Like draw me an angle that's 0. You can't. It could be 0.1. It'd be teeny tiny, but it could be 0.00001. It just can't be. It can't be 0. We good? Yeah. All right. So your homework. Oh, I have to publish it. Is on Canvas. It's what are we on? 5.6. Okay. There's also again a Quizlet of terms because this is the end of the chapter. Okay, tomorrow we're going to do something called constructions where you're actually going to use like a protractor and a ruler and make some stuff. Okay, it's a little different from what we've been using. You won't need to do it on the test, no. it's kind of to help you like visualize things and improve some of the proofs that we've been using. And then review also like point of concurrency and all that stuff. We'll do that tomorrow. But again, remember test is Tuesday. And again, it stops at 5.